Hello students and welcome to Math Weekly number 19. In this video, our focus skill will be on the basics of the Pythagorean Theorem. So let's begin with a definition of the Pythagorean Theorem. The Pythagorean Theorem is a consistent relationship between the three side lengths of a right triangle. For any right triangle, the sum of the squares of the two legs is equal to the square of the hypotenuse. As a visual, we have our short sides of the triangle, which are referred to as legs. These are formed to the left and right of the 90-degree angle. Across from the 90-degree angle, we have the hypotenuse. If you ever are not sure what side is the hypotenuse, you can draw the right angle symbol and then make it into an arrow, and it will point over to the longest side. Now, knowing these is very important because we need to make sure that our hypotenuse is labeled with the letter C, and that is part of our formula. A squared plus B squared to the legs squared equals the hypotenuse squared. If this is true, then the triangle is a right triangle. So there are some uses for the Pythagorean theorem. The first thing that it can be used to do is determine if a triangle is a right triangle. In other words, we're asking ourselves, does a squared plus b squared equal c squared? This is the focus of today's Math Weekly. We can also use it to determine a missing side length in a right triangle. We will touch upon how to set up an equation to be used to figure out a missing side, but that will be our focus in next week's Math Weekly. So let's practice determining if a triangle is a right triangle. Would a triangle with sides of 8, 12, and 15 form a right triangle? Now remember, if we want to know if it's a right triangle, we need to use the Pythagorean theorem, which says that a squared plus b squared equals c squared. Now, remember, the C is called the hypotenuse, which is the longest side of the triangle. So if we look at our three numbers here, the 15 is going to be our C because it's longer than 8 and 12. Therefore, 8 and 12 are our A and B. So when we substitute into our equation, which is a squared plus b squared is c squared, instead of writing A, B, and C, we are going to use the numbers that we just labeled. So A, which is the short side, is 8 squared. B, which is the medium side, which is 12 squared, is equal to the longest side called the hypotenuse, which is 15 squared. 8 times 8 is 64. 12 times 12 is 144, and we want to know, does that equal, we're asking ourselves that question, does that equal 15 times 15, which is 225? Well, if we add 64 and 144, do we get 225? We get 208. Is 208 equal to 225? And the correct answer is it's not equal. Therefore, this is not a right triangle. So a triangle with sides of 8, 12, and 15 would not be a right triangle. Let's try another example, one in which you need to create a depiction of the triangle itself. So at a local park, Benjamin walks 7 yards north and 12 yards east, and he believes that he's 20 yards from his starting location. Is Benjamin correct or incorrect? So we can see that he walked north and to the east, which creates a right angle. My picture's a little off, but you get the idea. And that creates a right triangle, which proves that we should have a squared and b squared added together to equal c squared if his prediction of 20 yards is correct. So he thinks that the shortest side, which is A, is 7. The shortest distance that he walked was 7. The medium distance that he walked was 12. And the longest distance that he walked was 20, or he would walk if he did. Now, simplify using our exponents first. 7 squared is 49. 12 squared is 144. And we want to know, does that equal 200? 400. 20 times 20 is 400. So add 49 and 144 together, and we get 193. Is 193 equal to 400? No. So he did not estimate this correctly. Benjamin's prediction is incorrect. Benjamin's prediction is incorrect. He is not 20 yards from his starting location. Okay, we're going to practice setting up accurate equations for determining missing side lengths. We're going to do one example like this. So it says, which of the following equations could be used to determine the diagonal length of a soccer field shown below? So what I like to do first when I have an unknown side is figure out which one is our C. So you can see our right angle here, and it will point to our longest side. So the side that we don't know is the C. The shortest side then is the 60, and the medium side is the 90. So if I were to do a squared plus b squared equals c squared, a would be 60, b would be 90, and c is the side that I don't know. So I'll leave it say c squared. Now if you look at our equations over here, they did not put c, they put x, that's fine. But we can see that we have 60 squared, just like they have 60 squared here in option C, plus 90 squared equals our unknown squared. So the correct setup would be setup C. So let's review what we've learned about the basics of the Pythagorean theorem. The Pythagorean theorem states a consistent relationship between the side lengths of a right triangle. And in the formula a squared plus b squared equals c squared, a and b are the lengths of the legs of the triangle, and c must always be the length of the hypotenuse. The Pythagorean theorem can be used to determine if a triangle is a right triangle, and also be used to calculate a missing side length for a right triangle.